Okay, today we're just going to look at the periodic table and then find charges. Charges are formed how? How does an atom get a charge?
Based on its gain or loss of electrons.
Right, based upon its gain or loss of electrons. Yep. If it gains electrons, its charge is a negative. If it loses electrons, its charge is a positive. If it loses 2, what's its charge? Positive 2. If it gains 3, what's its charge? Negative 3. Okay. So, and you guys already know why that loses and gains. I think most of you kind of understand why it will gain, why it will lose. The nonmetals to the right of the chart here are minuses because they tend to gain. And they gain to get over here, basically. And then we have some of these other that are charged that they'll lose. So metals lose, and they'll be a positive charge or a cation. And anions gain, and they become a negative charge. So then what they do is they get together and form an ionic compound. Well, we got a lot of these ionic compounds that formed, and we need to know how to write them and how to name them. Okay, you guys have to know. And it's not that difficult to do. Okay, it's pretty easy in the overall scheme of what you have to do in chemistry. Okay, so the first thing is we have to be able to read our periodic table. You guys will always have access to this periodic table. You will not have access to this chart up here. Okay, this chart is up here. We'll go ahead and reference it when we're looking at your periodic table here. Okay, so the first thing we'll look at is the plus charges. Okay, so you guys find the charge. The charge is listed on your sheet above the symbol on all the elements. So what's the charge of group 1? When you go down through all of those, positive 1. So they're all a positive 1. So if you look up here, I just have a positive 1 on that row because they're all positive 1. Okay? You look at group 2, they're all positive 2. Okay? Now, when you look at some of these ones in the middle, like chromium, I'm just picking out select ones, iron, nickel, and copper, they have what we call multiple charges. Okay, so here's chromium, and a chromium atom will do 3 things. It will lose 2, 3, or 6 electrons. Because it's in the middle and it's in the D sublevel, they tend to vary how many electrons they will lose, depending upon what they're paired with. So on those, we don't know exactly what their charge is unless we know how they pair with another substance. So on these, all in here, all these are examples where we're going to have to use a Roman numeral. We'll get to that here in a second. You guys don't have to write this down. I always have this. Now you guys know your Roman numerals, right? So Roman numeral for 1 is an I, right? And a 2 is 2I. And then a 3, 4, IV. 5, V. And then I don't think you have to go past that, but if you did, 6 is VI. Got it? So if it's a charge, if chromium, I tell you, chromium's charge is a +3, you're always going to have to put chromium free. Okay? If I say, or you find out that iron's a +3, you're going to have to say iron 3. Okay? It's kind of like, for example, we had a individual on our team last year. His name is Jason Stevens. His dad's name is Jason Stevens. Okay? So if I would call up to the house and I'd ask for Jason Stevens, they would probably ask, who do you want? A lot of times he went by Jace, but then later on he decided he liked Jason better than Jace. Because that's his name. That was his name, given name. So we have to stipulate over here with a Roman numeral, kind of like the kings. You guys learn anything about kings in England and France? And King Louis they always use a Roman numeral, right? A lot of times. King Louis, King George the whatever. And it kind of got into where they would represent, because they all had the same name, and they'd have to represent it by a Roman numeral. Like Pope, right? Pius that's our arch enemy, right? Pius the 10th. Okay? So the popes, they kind of similar concept, similar idea. So anytime you guys write chromium, iron, nickel, copper, you have to use Roman numerals. You have to. Now, with this row, these two rows, you don't, because we don't have to stipulate what the charge is, because we always know the charge of this group is a +1, right? So this group here is always going to be a +1. This group's always a +2. We don't use Roman numerals with any of these, but all of these we do. Now zinc, look up zinc, what's its charge? So zinc I do not have to use a Roman numeral for, because it can only be a +2 when it forms. Okay? Now, we're going to go over to the negatives. If you notice, I didn't include anything in the noble gases in the last row. I want you to find where the negatives are located, because there's a lot of numbers they give you, okay? And those numbers mean something, and they're important, but not for us at this point in chemistry. They're not going to mean anything to us because we're not going to use them. So, when you look at fluorine, chlorine, bromine, iodine, where is this -1 located on your sheet? What number is it? I mean, what's common in that number, and where is it located within the row? The last one, right? We're always going to use the last one when we have to find the charges of those. Any questions? Because that's the charge it's going to be when it forms an ion. What are all those other numbers? Well, that's when they're in what's called a molecular formula. So we don't care about those right now. Okay? We'll get to those eventually. Look at where they're located for oxygen, sulfur, and selenium. Where are they located? At the end, right? Okay? Make sure you're looking at the chart so you can kind of get familiar yourself with the chart. And then nitrogen, phosphorus, and arsenic, where are they located? At the end. So guess what you're always going to use? You're always going to use the charge at the end of all those numbers. That's the one you have to use when you do all these problems. Okay? If you go down below arsenic, you're going to start getting into metals. So that's why when you get down to bismuth, there's no negative because it's a metal. Okay? So you're going to, but most part, we're going to use this in which to write some formulas. So the first thing we're going to do is just write formulas. Okay? I'm going to give you the name, and then we're going to look at the name and kind of see what it means, and then just write the formula from it. These are all called binary ionic compounds. They're called binary ionic. Bi means two ions put together, and then we name them. So I'm going to go ahead, and we're going to go ahead and give you a name of one of them. Let's go magnesium. You can put this part in your notes, not with the periodic table. So magnesium fluoride. Okay, so is magnesium written any different than the name on the periodic table for magnesium? So when you look at the periodic table, you find magnesium, it's Mg. That is the name of its metal, right? Magnesium. Okay? Is there any difference between the fluoride and what's the name on the periodic table? Okay, so on the periodic table it's fluorine, and in the name I have fluoride. So let me tell you the difference. This is fluorine, and this is fluoride. What's the difference? It's a negative. I'm telling you the charge. So if you see something that has an IDE ending, it's an anion for a nonmetal. So fluorine is called fluoride. Chlorine is called chloride. Nitrogen, what do you think nitrogen is called? It's not called nitroide, it's called nitride. Okay, what do you think sulfur is called? Sulfide. How about phosphorus? Phosphide, not phosphoride, but phosphide. Okay? So these are all pretty much two-syllable words with IDE in when you have to write the name of it. We're not writing the name of it, but I just need to do that, explain that to you, so when you do, it'll make sense. So what I like to do is I'll put the charges, if I know them, above each of the names. So I look them up, and I look magnesium, it's a +2, and I look at fluorine, it's a -1. So now I have to put these together so that they equal 0. So the charges need to add up to 0. Do they add up to 0 right now? No, they add up to a +1. That's not good. So the one that's lower in charge, I always have to increase that by multiplying by a number that originally will get to my subscript, be used as my subscript. So which of these two do I have to multiply? The fluoride. And what do I have to multiply it by? 2. That becomes my subscript for F, and then this will not get a subscript because I only have one of them. So when I add these two together, I get 0. So my formula is MgF2. So magnesium goes together, 1 magnesium and 2 fluorines, and then that's the formula for it. So magnesium fluoride is MgF2. Any questions you guys have? Okay, that's about it. You just have to balance charges, and they get a little tougher, but not much tougher than that. So let's get you another one. Okay, let's do one that's not real tough, but I'm going to go ahead and give it to you and then see if you can figure out the formula. We've kind of done these already. At the beginning of last week, we did some of these, so it should be an easy transition for you. So we're going to do aluminum, and we're going to go bromide. So what you would do is write the charges above them, see how much you need of one with the lower charges to balance them out, and then write the formula. So by the end of this week, you guys will be able to write and name formulas for probably a combination of over 1,000 different types of compounds. Okay? So the combination of all the different ions that you can put together by the end of the week, and actually, yeah, by the end of the week would be probably over 1,000 different combinations I could come up with that you guys could write the names for and formulas for. Okay? And most students are very successful at doing most of this. So this is a +3 and this is a -1, so you guys know that when you add these together it won't give you 0, so you have to do what? You have to have how many bromides? 3. So you say, I'm going to multiply by that 3, and now it will be 0. That becomes my subscript. So if you had it as ALBR free, you would be right. We good? Okay. Now this is the toughest one that you'd have to write a formula for on binary ionic. So of just the ones we're doing today, this would be one of the toughest you'd have to do. So I'm going to go ahead and give you this one. And we're going to go ahead and go calcium nitride. I want to see if you can come up with the right answer for this one. This will be the toughest one you'd have to do. So calcium nitride, see what you can do with that one. Nitrogen is a -3, right? So just like in math where you have something that's 1/3 and you're adding it to 1/2, you have to do what? You have to get a common denominator. So I'd have to make this one 2,6 plus 3,6. So this, you're going to have to do the same there, right? So how many of these do I need? 3. And how many -3s do I need? 2. And so when I add those up, then I get 0. So it should be Ca3N2. How'd you guys do on that? Get them? That's all you need to do is that if you got one that's 2 and one that's 3, you've got to get both to 6. And then whatever you do to get either 1 to 6, that becomes your subscript. And then that's how they would even out to be 0. Okay? So let's have you do 3 of these. I'm going to give you 3 names. You write 3 formulas and see what you get out of 3. Okay? So here we go. Okay, so do those 3. Yes? Yep. Elements, then just more time off of you being able to do the test in a fair amount of time. So sodium's a +1, sulfur's a -2, so I have to have 2 of these, so that's Na2S. Zinc is a +2, nitrogen's a -3, so I have to have 3 zincs for every 2 nitrogens. So that's Zn3N2. And aluminum's a +3. Phosphorus is a -3. So that's Alp. Questions on those? That's all you're doing. Okay? Now, I'm going to introduce you just real quick, and I'll show a couple of these. So I'm going to write down this thing called lead 4 oxide, and I'm going to do copper 1 sulfide. Okay, so what I want you to do is I want you to find lead, and above lead there's 2 numbers, right? So above PB, there's 2 numbers. What are those 2 numbers? Is this just 4 and 2? That's it? Okay? So it's a +4 or a +2. You guys see why I have to tell you what the charge is? Because if I didn't, you wouldn't know which one to use. So if it's a lead 4, then it's what charge? +4, right? And oxygen's always a -2, so then that formula would be what? PbO2, right? Okay, so I go copper 1, that tells you what? There's a misconception, because sometimes students will take this lead 4, going back to lead 4, they will write it like this. Okay, because they think this 4 is how many leads you have. But this 4 represents the charge. And that charge allows you to write the formula correctly. So this is copper 1, so this charge is what? plus 1. Sulfur is minus 2. So I need 2 of these. So it's Cu2S to get them to work. So the Roman numeral indicates the charge. Okay, so when you see a Roman numeral, so that transitions us into this last part. We're just going to write some formulas out. Okay? So, or write some names out. So I'm going to give you a formula and you're going to write a name for it. Okay? We're going to do a couple really easy ones. I want to see, you should be able to do these without using a Roman numeral because I'm going to give you ones that aren't in the middle here. Okay? So I'm just going to have you write out 2 names from the formula. Let's have you write out this one. And this one. Okay, so write those 2 names out, what you think they are. Li2S and AlBr3. So this first one, the name of it is what? Lithium sulfide. Okay, and the second one's name is aluminum bromide. Really easy, isn't it? Okay, so we're good on that. Now, the last thing I need to show you has to do with these middle ones. Okay, so I'm going to go ahead and give you one, and we'll see if we can figure out which one of these ones listed is the one we're going to have to use a Roman numeral for. Okay? So I'm going to do this one. I'll do an easy one to begin with. So I'm either going to have to write iron 2 or iron free. So what you do is you go to the one you know. So do we know sulfur's charge? What's its charge? Negative 2. It has to come out to 0 when we add. So I need to fill in the blank. So what has to be iron's charge? Positive 2. So we use this one right here, correct? So we say iron 2 sulfide. Give you the charge, or give you the assignment, and then, I know I didn't leave you with much time, but that's just one of those days where you're going to have some homework. There's not a lot going, I guess there's a game, girls game tonight, but other than that, there's not a lot going on. Okay, so, your homework. This is pages 174 through 179 is the reading. Okay, you can just look for it. They give examples in that. And on page 179, you're going to do the following problems. There's a bunch of them that can be possible. So I'm just giving you certain letters to do. So 22A through D, 24B, D, E, and F, 26A through D, 30, we'll change things up and go C through F, and 32, C through F. All you're doing is writing names and writing formulas for those. Okay, on page 179. Okay, they shouldn't take too long to do, and I'll come and put it on a separate sheet of paper because I may have you turn this in for an assignment, so I can look over them better to see which ones are you're getting figured out and which ones aren't.